All right, welcome back. We are continuing with the 9.1, 9.2 homework. We're still in the two-variable part of this, and we are using the elimination method. That's probably the technique you're least familiar with. The substitution method is covered pretty heavily in other courses. So let's do the elimination method again on number 6, and we will see another situation. So 3x minus 2y equals 2. All right, now here we go. So we are trying to solve this by elimination. So what we want to do is get the opposite. We want this coefficient to be the same size but opposite. So we're going to multiply this equation, both sides, by a minus 2. That'll do the trick. Don't forget to multiply the other side by the minus 2 as well. And so the first equation is 6x minus 4y equals 2. That hasn't changed. And now our second equation is now negative 6x. Be careful here, you're distributing. It's a positive 4y. Notice we're getting some similar values again here. And then the right-hand side is a minus 4. All right, we're going to see something interesting here. When we add the two equations together, we get 0. We get 0. We get minus 2. Now, this is slightly different than our last example because 0 never equals minus 2. So that's a problem. That means this system of equations is inconsistent, that there is no solution. It's not like there's an infinite number of solutions. There is no solution. And you can tell that right away. Now, you got to be careful that you didn't do some arithmetic error, because if you made an arithmetic mistake, you could get this a similar result. So make sure you're adding correctly. But 0 is never equal to minus 2. So this is inconsistent. What it really means, so it means we have two lines, but they're parallel to one another. So they're independent of one another. And they're inconsistent. So two different lines, that's the independent part. Independent means they're two different lines. The inconsistent part is saying that there is no solution. There's a contradiction, in fact, because 0 cannot equal negative 2, minus 2. All right, so that's a little bit of that terminology. All right. I hope that helps. We will do some more elimination with the 3-variable problems. Why don't we go ahead and just jump right into it. So now we're on to the 3-variable problem. These are just like the others. Some elimination techniques would really make these a lot easier to handle. So it's just like the 2-variable, but we want to solve 3 equations simultaneously. Now these 3-variable functions are actually lines in or planes in higher dimensional space. We're not going to think about any of that, but there are multiple answers that can happen here. So let's do this. So we're trying to find an x, y, and a z that satisfies these equations, and we're going to use the elimination technique to simplify this problem, figure out what x, y, and z are. So the idea, so you take equation 1 here, and again, you want to make it opposite of the equation up here. Let's multiply this whole equation. You can see if you multiply by half, a negative a half, in fact, that actually reduces everything in a nice way. I know fractions aren't our favorite thing to do, but let's do that because it really simplifies things quickly here. So you get a negative x, a negative 2y. Be careful there. We're distributing it all the way through. A negative z, and on the right-hand side, a negative 1. Add the two equations together, and hopefully we will have some variables eliminated. Looks like we do. So negative x is 0. Y and negative 2y is negative y. The z's cancel each other. It's 0, and that's a positive 2. So we know what y is. Y has to be a minus 2. So this is the elimination technique. It doesn't always work out that nicely, but we already know what y is. So from here on out, y is a -2. Okay, now let's add these two equations together. Let me point it out in green here. They're already set up for us to eliminate, and we know what y is, so that's going to help as well. So let's go ahead and add x plus y plus z equals 3. We're going to add it to -x plus 7y minus 3z equals 19, and keep in mind we know what y is already. Okay, so when we add, we get 0, we get 8y, we get minus 2z equals 22. All right, but we're not in isolation here. We already know what y is. 8 times -2 minus 2z equals 22. Okay, so we got a -16 over there, so it's -2z. If you take that -16, you add it to the other side, you get a positive 38. And so z's got to be a -19, I think. Yeah, you might have to get out your calculator if arithmetic's not your favorite thing. But so now we know what y is. We know what z is. Now I'm doing a little bit of elimination. The first step was elimination. The second step was a little bit of elimination and a little bit of substitution. I substituted in what y was. We knew what y was. So our last is going to be just a pure substitution step. So we know that x plus y plus z has to be 3. That's the first equation. And so far we don't know what x is, but we know what y is. Y is -2, so we're substituting it in. We know z is -19, and we know it all has to add up to 3. So now we know what x is. So that's -2, that's -21. So we add 21 to both sides, and there you have it. X is 24. Now, all three equations have to be satisfied simultaneously. As long as you use all three equations in that development, and we did, I was very careful about that. I paired up the first equation with the second equation, the first equation with the third equation. I used those results back in the first equation. Make sure you use all the equations. And so our answer is 24. Now, you don't have to put that first parenthesis there. Our second term is -2. Our last is -19. So there is a single solution, and we found it. There it is. All right. For our last... sorry, I put it in the wrong slot there. Sorry about that. Okay. So that was A. There was one solution. That was number 7. For our last problem, number 8, we're just going to do that quickly here because we're going to see a slightly different result with that one. So this was number 7. Okay, on number 8, we're going to keep doing this elimination technique, and then bounce, you do a little substitution here and there as convenient. So feel free to be a little creative here. Our goal is to find out what these three things are. All right, there may not be a solution to this one, and I want to show you what it looks like when there is no solution. So here we go. Again, we're thinking elimination. Let's multiply this by a -3 this time, and remember to do it on the other side as well. And then we're going to add these two equations together. All right, so here we go. We got -9x. We got a positive 6y. Be sure and distribute. Be careful with your signs. -6z equals -6. Easy to make mistakes here. -6y plus 6z equals 8. Okay, I hope you see where this is going. So when you add those together, you get 0. You get 0. You get 0. And then you don't get 0. You get 2. That is inconsistent. 0 cannot equal 2. Now, as long as you didn't make a mistake, make sure you didn't make a mistake. Double check your distributing and all the stuff like that. But as soon as you get an inconsistent situation, there is no solution, and you don't have to go any farther. Now, if 0 does equal 0, then you're going to have to solve for the z solve for x and y in terms of z, and plug those into those two slots. But there's no solution on this problem, and we are done. Hey, take care, and remember, this material will be on the final exam, but there's no separate test for 9.1, 9.2. It's just going to be a couple extra problems on the final exam. All right. See you later.